Hello students, in this video, guess what topic we're going to do? Yes, we're going to do polygons. And do you know the name of the polygons shown on the screen? Do you want to find out more about polygons? If you do, please stay to the end of the video. Right, let's start off by deriving the formula to calculate the sum of interior angles in the polygon. Let's start off with the triangle. Basically, a polygon is just a figure that has three sides and above. So the minimum number of sides is 3, and that is a triangle. And the sum of the interior angles in the triangle is 180 degrees. Right, basically these three angles will add up to be 180. Angle A plus B plus C will give you 180. That's how I get 1 times 180 here. All right, and then 1 is actually number of sides. 3 minus 2. 3 minus 2 gives you 1 times 180. Right, and let's see whether we can continue with this trend for the quadrilateral for the rest of the polygons. All right, so a quadrilateral is a four-sided figure. So what are a four-sided figure? Can you think of one? Yes, it can be a square, it can be a rectangle, it can be a parallelogram. So if I have a rectangle, you see that I can actually dissect it into two triangles. And since the sum of angles in the triangle is 180, since I have two of them, is 2 times 180. And to get this number 2 here, basically, I just take the number of sides, which is 4, minus away 2. Right, 4 minus 2 will give you 2. So it seems that the trend holds for quadrilateral also. So now let's look at pentagon. So a pentagon is a 5-sided figure, and we can dissect it into 3 triangles. Right, and that will be 3 times 180, and 3 is basically just taking the number of sides, which is 5 minus 2. And if you were to continue, you see that it works also for hexagon, it works also for heptagon, works for octagon, works for nonagon, works for decagon. So therefore, if you have a polygon with n sides, so the sum of interior angle will be just n minus 2 times 180 degrees. So if you have a polygon that's 11 sides, then the sum of interior angles will be 11 minus 2 times 180. Right, and if you have a calculator, you can just work out the value. Right, so in summary, this is a formula you need to remember. And this formula works for regular or irregular. Okay, a regular polygon is such that all the sides are of the same length and all the interior angles are the same value, have the same value. That is a regular. A irregular means the sides don't need to be same length and the interior angles don't need to be of the same value. However, the sum of interior angles, the formula to find the sum of interior angles is still the same, which is bracket n minus 2 times 180 degrees, regardless if it's a regular or irregular. Right, so let's do some examples. Let's do a recap. Yeah, we have just done it in the earlier slide, but it's okay. Let's do a recap of what we have learned earlier on, and that is the sum of interior angle in the polygons is bracket n minus 2 times 180 degrees, and n to represent the number of sides in a polygon, whether it is a regular or irregular polygon. So let's look at how we can calculate. For example, in example 1, right, if you are given a in this case here a pentagon, 5-sided figure, right, so you just substitute n to be 5. That will be bracket 5 minus 2 times 180. If you use a calculator to work this out, it will be 540. Right, so basically it's just substituting the number of sides into this variable n there. Let's look at the second example. Okay, and in this case here, the interior angle will be 540 divided by 5, 108. And this has to be a regular pentagon. Regular meaning all the interior angle needs to have the same size. That means all the sides are of the same length. Right. So let's go on to the second one. Okay, if you look at the figure quite clearly, this is not a regular, this is an irregular hexagon. Right, so the sum of interior angles is 720, and we cannot take 720 divided by 6 because the interior angles, if you look at it carefully, they are all not of the same size. Like this one is a cube, this is obtuse. Alright, so for irregular shaped one, alright, the angles are not the same. So therefore, you cannot take the sum of the interior angles to divide by the number of sides. Right. Okay. So we have learned how to find the sum of angles in the sum of interior angles in the polygon. How about sum of exterior angle? So the sum of exterior angles in the polygon is 360 degrees, and I'm not going to show you how to derive that. It's quite complicated. Right. Showing you how to find sum of interior angles is easier. So we're just going to accept that sum of exterior angles in the polygon is 360 degrees. And therefore, to find one exterior angle, you just basically take 360 degrees divided by n, where n is the number of sides in the regular polygon. So let's have an example. If you look at the example given there, that is a pentagon. Right, that's a pentagon. So pentagon has 5 sides. So if you take 360 divided by 5, then the exterior angle is 72. And therefore, the interior angle will be 180 minus 72, which is 108. And which is what we get here. Right. So it kind of makes sense because the interior angle plus the exterior angle will give you 180 degrees. Okay. So the exterior angles, it will be all 72 degrees here. Okay, and this one refers to a regular pentagon. Right, so let's do some basic questions. Basic questions as we just use the formula to apply the formula directly to find the unknown angle. So supposing you're given the irregular quadrilateral here, let's find the sum of the interior angles first. So that will be bracket n minus 2 times 180. So that will be 4 bracket 4 minus 2 times 180 gives you 360 degrees. So what we are saying is that 130 plus 61 plus 65 plus x will give you 360, and therefore x will be 104. And so this is an irregular quadrilateral where all the interior angles are of different size, the sides also of different length. Let's look at another one. Again, another irregular one. So it's a 5, 1, 1, 2, 3, 4, 1, 2, 3, 4, 5-sided figure. Let's find the sum of interior angle first. Right, and basically you just add up all the interior angles equals to 540, and x will be just 108 degrees. Okay, let's look at the next questions on how we can actually use the formula, which is the sum of the exterior angle equals to 360, right, to find the unknown x. Right, so basically we just add sum of exterior angles is 360, so basically we just take x plus 112 plus 101 to give you 360. And from there, x is 147. So this is quite straightforward. Likewise, for the next questions, basically you just take all the exterior angle, add it up to be 360. And from there, you can find x to be 85. Right, now let's do a slightly harder questions. This question is such that you're given the ABCDE is a regular pentagon, 5-sided figure. Oh, by the way, you need to know the names of all the polygons up to 10 sides. All right, in your O-level syllabus. N-level syllabus. Okay, you need to know all the 10 sides. That's all you need to know. So a pentagon is a 5-sided figure. All right, so let's have a pentagon. And then the sides A, B, and DC produce. When you say A, B, and DC produce means basically you just draw the line AB longer. AB produce means you draw the line AB longer. DC produce means you draw the line DC longer. And when you draw these two lines longer, and then they will just meet at point F. This is what it means. And you ask to find the angle XYZ. Okay, finding X is easy. Okay, it's a regular pentagon. So we just use the formula to find sum of interior angle and then divide by 5 to gives you one interior angle. Okay, right. And to find Y is easy also. Basically, it's sum of angles on the straight line. And so Y will be just 72 degrees. Okay, so to find Z, we need to learn a new angle property, which is good to learn. If not, then you will have, if you don't learn it, you will have more steps to find Z. You will have to find this angle, which is 180 minus 108. Oh, so that is 72 also. And Y is 72. And then take 180 minus 72 to give you Z. But I'm going to teach you another angle property that will make your working lesser. So this angle property, it's if you have a triangle, right, a triangle, and then if you have one exterior angle, so basically the two interior angle, this two add up will give you the exterior angle. Okay, right, let's have another diagram. You can start off with any triangle. Let me draw a triangle like that. Okay, so the angle outside your triangle will be this guy here. This is the one outside. And the two inside will be away from your angle C, away. So A plus B will give you C. Okay, let's draw, let's say if I don't want to use this. Let's say I want to extend this longer. I want to use this angle. This is my angle C. Right, then of course my A cannot be there. My A will have to be here. Okay, so A plus B give you C. Right, so basically Y plus Z will give you X. Alright, and the reason is exterior angles of triangle. And so therefore Z will be 108 minus 72 give you 36, which is the same answer you get if you take 180 minus 72 minus 72. Alright. Right, let's look at a slightly harder question. In these questions here, you're given a hexagon and also a square. Let's see how the picture looks like. So A, B, C, D, E, F, it's a hexagon. Hexagon is a 6-sided polygon. And then A, B, G, H is a square. And you ask to find angle ABC and angle CBG for part A. And for part B, we're asked to find all the angles inside the triangle ACG. Alright, so let's look at part A first. So for part A, let's find the sum of interiors angle of a hexagon. Right, if we were to recall the formula is bracket n minus 2 close bracket times 180 degrees. That is for the sum of interior angles of a polygon, and n represent the number of sides. N represent the number of sides of the polygon. In this case here, hexagon has 6 sides, so we substitute n to be 6. Alright, so we get 720. So therefore, one interior angle will be 720 divided by 6. That gives you 120. So therefore, angle ABC is 120. So that is part A. To find CBG, right, we understand that ABGH is a square. So therefore, angle ABG is 90 degrees. And the reason being it is an angle in the square, right? And CBG can be found by taking 360 minus 120 minus 90. That gives you 150. And the angle property is we're using angle sum at the point because angle at the point is 360. So by taking 360 minus 90 minus 120, that will give us angle CBG. Right, so we are done with part A. So to do part B, let's list down the angles that we need to find in triangle ACG. So what are they? Right, so basically the angles in triangle ACG are angle ACG, this one here, angle CGA, this one, and then CAG. Right, so let's, all right, so we are told that ABCDEF is a regular hexagon. Regular hexagon means all the interior angles have the same value, and ABGH is a square. So therefore, regular hexagon also has all the sides having the same value. So therefore, BC is equals to BA. And because ABGH is a square, so AB is also equals to BG. And what is so important about this? Yes, it makes your triangle ABC an isosceles triangle. So this one here is an isosceles triangle. Right. So to find BCA is equals to BAC equals to 180 minus 120 divided by 2 gives you 30 degrees. Right. The reason being their base angle of an isosceles triangle. All right. Then let's go on to find what other angles we need to find. All right. So that's 30, 30. And so therefore, okay, hang on. Oh, and we also go on to find angle BCG. Right. So BCG is basically triangle BCG is basically the isosceles triangle also. If you look at the diagram, the length BC is equals to BG. Right. So BCG is equals to BGC equals to 180 minus 150. We found CBG earlier on to be 150. This one is 150. So let's label it. Then you will know what's going on. So this angle here, it's 150. We found it earlier on in part A. Right. So we're going to add these two angles together. Okay? I did label it. Sorry. Okay. So we're going to add that two angles together to get 45 for angle ACG. Right. So it's labeled quite nicely for you. The green color one, that's 30 here, plus the purple one, 15. That gives you 45. All right. So how about the next angle? So CGA will be basically 15 plus 45. So where did this 45 come from? 45 is because our ABGH is a right angle triangle, right? And then your AG is the diagonal. So that makes this guy 45. Okay, don't use this one, it's too thick. So make this 45. Also make this one here 45. Alright, so basically it's just 15 plus 45 gives you 60. Alright, and then the last angle CAG will just be 30. Highlighted for you in green. Plus this one is also 45. And that gives you 75 degrees. Right, let's look at question 3. Question 3 is a rather interesting question. Alright, you're given two regular hexagons placed side by side. and A part I, you're supposed to find the angles x, y, z. So that is relatively easy. Let's go on to find the sum of interior angles in the hexagon, which is bracket 6 minus 2 times 180, give you 720. And to find one interior angle is just 720 divided by 6. All right, so angle x will be equals to angle y because the two hexagons are identical meaning they're congruent. So angle x will be equals to angle y, which is just 720 divided by 6120. Right, and to find z, we just use 360 minus 120 minus 120, angle sum at the point to get 120. So basically x, y, z have the same value, which is 120 each. All right, so A part 2, you ask if you can have another identical hexagon to place in angle Z. So what they're saying is that, can I put another hexagon here like this? And the answer is yes, because the interior angle in the hexagon is 120, and your angle Z is 120. So it will fix nicely. So the explanation is that since angle Z is 120 degrees, which is the size of the angle of a regular hexagon, an identical hexagon can be placed to fill the angle without leaving any gap. Right, so to do part B, these are some of the patterns that we can have. Right, 6 of them. You need 6 hexagons. So you see that these 2 sides, common sides, these 3 are the common sides. These are all the common sides. This is what it means. All right. Another possible one will be this. So you can try to form some other similar patterns on your own. This is just 2 examples. Right, so it's time to do an O-level questions. This question is taken from the year 2017 to paper 1, question 8. So in these questions here, we have a regular pentagon. Pentagon is a 5-sided polygon, and attached to it is another regular polygon, which we are supposed to find the number of sides that this polygon. In other words, if we were to continue with it, what we are asked to find is the number of sides of this second polygon. All right. So since A, B, C, D, E, it's a regular polygon, so we are saying that they have the same interior angles. So in other words, your CDE, angle CDE is also 108. And CDF is given to be 96, so we can just use angle sum at the point to find angle FDE. Right. So to find the number of sides, we're going to use the sum of the exterior angles to find. So if you were to remember sum of exterior angle, equals to 360 degrees. So therefore, one exterior angle will be 360 degrees divided by n. Okay, right. So how do we use that? So we need to draw the line ED longer, extend it longer. So you form a straight line. So basically, this angle here, your 156 plus this angle here will give you 180. So that will be 180 minus 15624. Okay, let me erase this. So that is your exterior angle. So to find the number of sides, you just take 360 divided by n to give you 24. Right, so you just do a cross multiply, and n is 15. Okay, so that is how you use the exterior angle to find. That's a slightly longer method where you use the interior angle, which I will not advise you to, but if you're very good in your algebra, you can try doing it. So how do we use that? That it's we know that to find the interior angle is bracket n minus 2 times 180 divided by n. Right, and then we do a cross multiply, and we expand this to get 180n minus 360. Then you group all your n together on one side, simplify it, you will still get the same answer, which is 15, but it's slightly longer than using the exterior angle. So you can choose which one you prefer. If you want to use the longer method, then you have to be careful with the algebraic manipulation. Not to say that you don't need to be careful with this, it's just that it's slightly longer, so chances of making mistakes are higher lah. Right, let's look at another question. This one is from the year 2016. This one is slightly harder because it actually involves the concepts of congruency. Right, in part A, we are asked to explain why triangles ABC and CDE are congruent. So talking about congruent triangle, okay, I hope you can remember there are a few rules on congruent triangle. One of them is side angle side. One is AAS, RHS, and side. So if you have forgotten all this thing, I did a video on this, so please do refer to it. All right. So how do we go about proving that the two triangles are congruent? Yes, first of all, since we are talking about this polygon being a regular one, how do you know it's a regular one? You see this word given to you is a regular one. So therefore, your angle ABC, the interior angles will have the same value. So angle ABC will be equals to CDE, right? And all the sides AB is equals to BC is given to you. It's given to you here that they are the same. Likewise also for this. And of course they are the same because we're talking about regular polygon. Alright, so you see that I have side, angle, side, right? Side, angle, side. So therefore these two triangles are congruent using SAS. Alright, so that is part A. Right, so let's look at part B. B part I, you're supposed to find the values of n. That means you're supposed to find the number of sides of a polygon. Right, so you're given angle ABC is 160 degrees, right? And triangle ABC, okay, so we're going to use the exterior angle again. Sum of exterior angle is 360. So 360 divided by n will gives you the one exterior angle. Alright, so we're going to extend the line longer again to form a straight line so that your ABC will be your interior angle and then 20 degrees is exterior angle. How to get 20 is 180 minus 160. This one is 160, right? So sum of angle in the straight line. So it's 180 minus 160 give you 20. Right. So 360 divided by n gives you 20 degrees. Just do a cross multiply. And therefore, n will just be 18. Alright, so that is B part I. Okay, B part 2, angle BCA. Right, so we know that triangle ABC is an isosceles triangle because AB, you see this sides, they're equal. AB is equals to BC, so that makes ABC an isosceles triangle. So just use 180 minus 160 divided by 2 gives you 10. Alright, the reason being base angle of an isosceles triangle. Right, so DEA is slightly harder. DEA is slightly harder as in like to find DEA, I would have to find CEA. Alright, I have to find this one here. I know that this little angle here is 10. Alright, it's 10. So I need to find CEA. Alright, so we know that if ABC is congruent to CDE, that makes the value of AC equals to CE. Right, and if CA is equals to CE, that makes triangle CAE isosceles. And therefore, we can just, to find ACE, you just take 160. Okay, 160 because the sum of the interior angle, it's 160. This one we already found, or we're given this interior angle to be 160, right? So by taking 160 minus away this little bit here, which is 10, another little bit here, which is 10, right? That gives you 140. So this angle here is 140. Okay, because the little thing here is 10, and this little thing here is also 10. All right, that's why it's 2 times 10. Okay, and then we just take 180 minus 140 divided by 2 again. All right, to get 20 for CEA. All right, base angle of isosceles triangle, and we add 20 plus 10. So here this is 20, and this little angle here is 10, right? So 20 plus 10, that gives you 30. Right, that's how we do it.